Hey guys, welcome to Unit 4, Section 1. So this is the first video of Unit 4. And this unit is about quadrilaterals, which is four-sided figures. And we're going to be looking at a bunch of different types, which you've seen in the past, but we're going to get more specific into the properties. So the first one we're going to talk about is called a parallelogram. And here's a list of properties that you'll need to know. A parallelogram is a four-sided figure that has, the first is opposite sides are parallel, which that's why it gets its name, parallelogram. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. Now when it says consecutive angles, those are angles that are like next to each other. Opposite is across from, like with the diagonals. And then lastly, number 5 is diagonals that bisect each other, meaning when the diagonals intersect, they cut each other in half. So here's some examples of what parallelograms look like. Just to recap a few of the features. So this one here, these are considered opposite sides. So this is, step number 1 is opposite sides have to be parallel. Okay. Or property number 1, I should say. It's not a step. Same for these as well. These two here would also be parallel with each other. Okay. And then opposite sides are congruent. So this side is congruent with this side is congruent with this side. Step 3, or property 3 is opposite angles are congruent. Now these are opposite angles. So this one here is across from that angle. These two are opposite angles, and they definitely look the same too, visually. Consecutive angles are supplementary. This would be an example of two consecutive angles. So let's say this one's 130, then that would mean this one is 50. These two here and here are also consecutive angles. Therefore, this is 50, which makes sense since we know that this angle and this angle have to be congruent. And then diagonals bisect each other. So I'm going to do it on a different diagram. I'll do it on this one over here. But when we form the diagonals, endpoint to endpoint, and then we do the same here, it causes this to be the midpoint of both of those segments. And now we get two sets of congruent segments. So those are parallelograms. Okay, and we're going to do different solving, and we're going to get more specific because there's different types of parallelograms, as you're going to see on this next slide. Now these ones are definitely more familiar to you. A rhombus, a rectangle, and a square are all types of parallelograms. They're specific forms. In order to be a rhombus, though, it's a parallelogram that has 4 congruent sides. Now, we don't need to know anything about the angles as long as it's a parallelogram, so it meets all of the criteria that we listed up above, and it has 4 congruent sides. That's what's classified as a rhombus. A rectangle is a parallelogram with 4 right angles. This time it's the reverse. We don't know anything about the sides. Well, we do know some features. We know that opposite sides of a parallel or of a rectangle are congruent, but we don't have to have specific lengths. But their angles have to be 90 degrees. We know that's true for all rectangles. And then a square is even more specific because it's a combination of both ideas. It's a parallelogram that has 4 congruent sides and 4 right angles. We know that to be true for all squares. So here's a little visual recap of how they relate to each other. So we have the general quadrilaterals that don't fit into any of those categories of rhombus, square, or rectangles. That's like these examples that we looked at up here. And then, like I said, rhombuses, squares, and rectangles are more specific, squares being the most specific because they have to meet all those different properties. Now, a square is always, technically there's 4 different things we could classify as a square. We know that a square is a rhombus because it has 4 congruent sides. A square is also always a rectangle excuse me. It's also a parallelogram. And then the last one, I'm not going to write it here, but it's also a quadrilateral because it's a 4-sided figure. And then with a rhombus is sometimes a square. You don't have to have a rhombus, since all squares are technically rhombuses. It's true that if a square is a rhombus is a square. Like, you can go either way, but you can't go, let's say this example right here. This is definitely not a square. We can't convert it, but it does have 4 congruent sides, and it's a parallelogram, so therefore it has to be a rhombus. It can also be a rectangle, because if it's a square, it has to be a rectangle as well. Same idea for a rectangle. A rectangle always has 90 degrees, but the sides don't always have to be the same. So it's sometimes a square, and it's also sometimes a rhombus if it's a square. Okay, don't let this get too confusing. I'm sorry if the wording wasn't great there, but we'll practice this more. Okay, then some theorems that have to do with a rhombus. In a rhombus, and therefore also in a square, we know that the diagonals bisect, meaning to cut in half, the opposite angles. So this angle here and this angle here get bisected by the diagonals going through that. Same for these. These are opposite of each other, but they get cut in half. The other one is they are perpendicular. Diagonals are perpendicular to each other. Okay, meaning that they meet at a right angle, technically 4 right angles, all right there. In a rectangle, and therefore also in a square, the diagonals are congruent. And this one we could prove using congruent triangles. And if you think about a square, if we go back up to our square image here, the distance from here to here is actually the same as the distance from here to here. And it's also true for rectangles. You don't have to draw this in, but I just wanted to show you. The distance from D to B is the same as the distance from A to C for both examples. All right, last slide here, we're just gonna do some calculations. Now we have to use those properties that we talked about up above. X equals Y equals, so we're solving for X and Y. Notice right here, we have, this is angle S, is 2x minus 1. The only other angle that we're given is this angle here. And we have to remember that this is technically a parallelogram. It's a rhombus because it has 4 congruent sides. But parallelograms, when you have the side-by-side angles, those are supplementary. That's one of the, sorry about that. It's one of the properties listed up here. Consecutive angles are supplementary. It's this one right here, number 4. Let's go back down to the bottom. And supplementary, if you recall, means to add to 180. 2x minus 1 plus 127 equals 180. We get 2x plus 126 equals 180. Subtract 126. 2x equals 54. Divide by 2. And we get x equals 27. And we can plug it back in to check it out. Now y, we're not looking at the angles anymore. We're looking at the sides. And we have 4 congruent tick marks, which means the sides are congruent. So we just set them equal. 6y minus 5 equals 3y plus 7. Subtract 3y. Add 5. And we get 3y equals 12. Divide by 3. And we get y equals 4. So just some basic solving there, recognizing the properties and then applying it. For this next one, the measure of angle QPR is equal to what? So QPR is this angle right here. This tells us that it's a rhombus. So if we go back up to these rhombus properties, remember that the diagonals bisect the opposite angles and they're perpendicular to each other. Since this is bisected and we know that this angle is 30 degrees, that also means that this angle is 30 degrees. So there's our answer for this one. Then we have QTP, which would be this angle right here. And we know that the diagonals are perpendicular to each other, so technically that's a right angle, which is 90 degrees. Lastly, QS. So the distance from Q to S is got to be 2 times bigger than this, since this gets bisected. So these two are congruent to each other, therefore it's 6 and 6, so we get 12. All right, go ahead and submit your notes and then watch the next video, and you can try the homework after you're done with the second video.